Today we switch gears from graphing to solving equations, and we'll talk about systems today. System of equations is basically two or more equations with the same variables. Freshman year we talked about three ways to solve these things: graphing, substitution, elimination. We'll do the same today. Freshman year it took us about 4 days to get through all this. Today we're just going to be reviewing the freshman concepts in a day. So when we talk graphing, if a system has one or more solutions, it's consistent. If it has one solution, we call it independent. And as you can see here, two equations, one solution, the graphs intersect at one point. System with infinitely many solutions, we call dependent. And it has infinitely many intersections. In other words, one graph is graphed on top of another. A system with no solutions is inconsistent, and the two graphs for this system will be parallel, thus no solutions. Let's start with our graphing approach first. You'll notice that they want us to graph the system to determine the number of solutions. If it's got one solution, you name it. So neither of these are in slope-intercept form. I'm going to take and put them there. So this is y equals negative 2x plus 6. This is 2x plus 2 equals y. So let's graph the top one first. Go up to 6. Go down 2 over 1. So connect the dots. Something like so. Then go up 2 and up 2 over 1, up 2 over 1, connect the dots. So it's pretty simple to see in this equation that these intersect at the point 1, 4, which means that if I plug in the point 1 for x and 4 for y, both equations should be true. So I have 2 times 1 plus 4 should equal 6, and sure enough, 6 equals 6. In the second equation, 2 times 1 minus 4 equals negative 2, and negative 2 does equal negative 2, so we solve the system. The problem with graphing is it's not always going to yield these nice intersections, so it's a little sloppy way to go about solving the system. When we talk about substitution, we talk about solving for one equation in terms of one variable, and then taking and substituting for that variable into another equation in order to solve the system. So let's do that. This is already set up nicely for substitution because we know that y equals negative 4x plus 12. So if I go to this bottom equation and say I have 2x, and instead of y, I plug in negative 4x plus 12, once again that's representing y, and set that equal to 2. Now I have one equation with one unknown. I can go ahead and solve that. That's negative 2x plus 12 equals 2. Therefore, negative 10 equals negative 2x, and x equals 5. To solve the system, I plug this back in to one of my two equations. I'll say y equals negative 4 times 5 plus 12, or negative 8. So my solution is 5, negative 8. And again, I can check that. We'll do this one more time and then we'll stop checking. I need y to equal negative 8 equals negative 4 times 5 plus 12. And certainly that's negative 20 plus 12, which is negative 8. Good to go there. And then 2 times 5 plus negative 8 should equal 2, and 10 minus 8 is equal to 2, and it checks. Let's do one more of this type. You'll notice in this case, neither equation has a variable isolated, so we're going to have to do that to make a substitution. It's pretty easy to see that this is the easiest equation to get a variable by itself in and eliminate any kind of fraction calculations. So we have x equals 2y minus 3. I can take that x value and plug it in. Therefore, I have 3 times 2y minus 3 plus 5y equals 24, and 6y minus 9 is equal to 5y, or plus 5y, sorry, is equal to 24. I have 11y is equal to 24 plus 9 is 33, and y equals 33. Haven't solved the system. I now have to plug this 3 back up to get my x. So x equals 2 times 3 minus 3, or 3. Therefore, my system solution is 3, 3. So we've done graphing, we've done substitution, we talked elimination now. And if you recall, elimination means multiplying one or both equations by a number so that we can try to have two equations with an opposite term in them, thus adding them away, eliminating a variable, and then solving our system. So let's go through and do that. So you'll see here I have two equations, two unknowns. If I try to do substitution, it's going to be painful because I'll get fractions all over the place. But I notice here, if I were to take and multiply both sides of the bottom equation by 3, I now have first equation, which is 5x plus 6y equals negative 8. And my second equation becomes 9x minus 6y equals negative 48. This is nice because now if I add these two equations up, I have 14x and my y actually disappears because 6 minus 6 is 0. That's equal to 56. Divided by 14, x is equal to 4. I want to find y. I have to plug the x back into either of these two equations. Doesn't matter. I'll say 5 times 4 plus 6y equals negative 8. Bring that 20 over, so I have negative 28 is equal to 6y. May not be pretty, but y equals negative 28 over 6. 2 goes into both, so that's negative 14 over 3. Therefore, my solution for negative 14 over 3. So in this case, we don't have a situation where I can multiply either equation by a single number, or an integer number, let's put it that way, because I could always multiply by a fraction, but I can multiply by an integer to make one part of the equation look like the other. So I'm going to take and try to find two numbers that I can multiply the top by and the bottom by such that one of these guys match and are opposites. I'll multiply the top by 2, the bottom by negative 5. That way on top I get a negative or positive 10y, bottom negative 10y. Therefore 8x plus 10y is equal to 6. Negative 15x minus 10y equals negative 20. Negative 7x equals negative 14, and x equals 2. Plug back in, I have 3 times 2 plus 2y is equal to 4. 2y equals negative 2, and y equals negative 1. Therefore, my solution is 2 and negative 1. Got to throw a word problem in here. Book club charges a membership fee and a fixed cost per book. After buying 6 books, Jake owes $17, and after buying 10, he owes $25. What's the membership fee and what's the cost of each book? You might be able to do this in your head, but I'm going to want an algebraic model. So I need two variables. One for the fixed cost per book, call that y, and one for the membership fee, x. The membership fee is the same in both situations. So I need to know basically what the books cost. And I've got 6 books in this case, 10 books in this case. So if I charge the first guy his membership, tack on a cost for each of the 6 books, I get a total of $17. Whereas the second guy, charge him his membership, charge him a cost for each of his 10 books, that person's going to go 25 bucks. And there's my system. Now what I can do is I can multiply this top equation by -1. In doing so, I have negative x minus 6y equals -17. Some of you might have been saying, can you use substitution? Sure, go ahead. I just chose to use this method. So now I add up and I get 4y is equal to total 8. 2 equals y. So now I need to find my x, or my membership cost. I'll plug back in. I'll get x plus 6 times 2, 17. X equals 17 minus 12, which is 5. So we've got a membership equaling 5 and a per book equaling 2. That's all we've got for today. Do your lesson summary, problems for lesson 14 in Connect Ed. We'll see you tomorrow.